So this is the review on chapters 1, 2, 3, 4, and 5. Like I said, we will be having a final at the very end of the year, including these chapters and chapters from volume 2. So we are going to start with chapter 1. These problems come exactly from the makeup tests that we've been doing. So this one, find the greatest common factor, the GCF, of 21, 35, and 49. So I want you guys to do that on your paper. So the trick to solve for greatest common factors is you initially pick the smallest of the numbers given to you. You pick the smallest, and then you find the factors of that number. The first factors are 1 and 21. Who can tell me what the next pair of factors are, Trey? 3 and 7. Excellent. What we do now is we work our way down from biggest to smallest. Does 21 fit into 35? Does it?
No.
Like, as a factor, is 21? No, it does not. Now we check 7. Does 7 go into 35? Yeah, so that one works so far. Then we check it with the next one. Does 7 go into 49? Yeah. Since that was the biggest one, we started from biggest to smallest. That's our answer. If we started with a different one, we wouldn't necessarily be able to work. Yes, in this case, 49 would work because our only factors are 1 and 49 and 7 and 7. But this is an easy way when we have factors that don't necessarily work out as nicely as we would hope. We'll see that again in the next example. A gardener has 27 pansies and 36 daisies. She plants an equal number of each type of flower in each row. What is the greatest possible number of pansies in each row? So yet again, what we're going to do is we're going to pick the smaller of the two factors, or of the two multiples. We're going to pick the smaller of the two multiples. This should be obvious. Which is the smaller of the two multiples, Trey? 27. So we're going to do our 27. We find our factors of 27, 1 and 27. Who would like to tell me the next group of factors? The next group of factors. Yes, Daniel. 3 and 9. Is there any other ones?
Yeah. 3 and 3.
3 and 3? That makes 9. So is there any other factors for this? No, there are no other factors. So now we think about it, we go again from the biggest to smallest. 27, is that a factor of 36? No, it is not. I see all the heads shaking. 9, is that a factor of 36?
Yes.
We see yes, it is. So, it is. So that means that the greatest number that we could plant in the row would be 9. Our answer would be 9. So these are pretty simple. My suggestion is always start with the smaller multiple, find the factors of that, and then start from biggest to smallest. That will help you determine if they have matching factors, if there is a GCF at all. And it's important when we get much larger numbers. This is really helpful when we get much larger numbers. So, our next one. Find and simplify the ratio of how many people like cats compared to the total amount of people. So we're going to look at this, and I want you to take time to solve this problem. And remember, we don't shout out answers. There's 2 ways to write a ratio. What's the first way that comes to your mind when you write a ratio, Miles? Something over something, not something over 1. Something over something. What's the other way that we can write a ratio? Who knows the other way? This is my favorite way, Hannah. Yeah, kind of like that. So we would write it, though, with 2 dots like that, with a colon between it. That's what it's called, a colon, not like inside our body. But, so, these are the 2 ways that we would write it. In this case, it would be cats to total, and here it would be cats to total. So those are the 2 ways that we could write our ratios. Now, these are simple. How many cats did people prefer? What was the answer for cats that people prefer, Romario? 8 cats. So we would write it like that. Now, this is trickier for people. What is the total number What is the total number?
52.
52. Nathan, how did you find the total?
I added them up.
You added them up. Total means add. Did you include cats in the total?
Yeah.
Yes, because that's part of the total amount of people. A lot of people forgot to add cats in, which made it wrong. Now, is this our answer?
No.
No. What do we have to do to make this our answer, Lucy? Simplify. This is the same thing. We're finding the greatest common factor. That's what simplifying is all about, finding greatest common factors. So, if you don't know the greatest common factor, my suggestion is just divide. If they're both even, just keep dividing by 2 until you get to the end. But who happens to know the greatest common factor? Let's see, Trey. You don't know? Gore? 4 is the greatest common factor. What happens? I want to see fingers. What happens when we divide 8 by 4? Fingers up. I see 3 people's fingers up. There we go. Yes, it is 2. So the same thing would be here. And then what happens when we divide 52 by 4? Who can tell me? Who can tell me, Fernando? Yes, it's 13. It is 13. Once again, I want to teach you just a separate trick. It may make sense to some of you. It may not. I'm just going to show you really quickly. If I can't do the math in my head, I split 52 into numbers I know that I can divide. So for example, 52 is the same as 40 plus 12. That makes sense, right?
Yeah.
That makes sense. What's 40 divided by 4? What's 40 divided by 4? We get 10. What's 12 divided by 4? We get 3. So we add those together and we get 13. So that's another way that you can look about this. Okay. Those are the 2 ways that we can write it. We can either write it as 2 over 13 or 2 colon 13. Both ways are ways that you'll see ratios, so don't be afraid if you see either way. You have to know that they can be written either way. Okay, same thing here. We're doing 2 problems. This is the first one. Find the equivalent fraction. So in this case, we have 4 over 5 equals 28 over something. How do we do this problem? Who can tell me how we do it? Michelle?
You have to see how many times 4 goes into 28.
Perfect. We see how many times 4 goes into 28. Whenever we do this, we draw the arrows to the unknown. So do you see how we draw the arrows to the unknown? That's how we do this. So how many times does 4 go into 28, Lucy? 7 times. So what we do to the top, what do we say?
We do the bottom.
We do to the bottom. So what's 5 times 7? Raising our hands. I'm going to see Trey.
35.
35. So our answer is 35. There we go. That's it. Now, for the next one, the results of a car race are shown. Who was the fastest? This was tricky for almost everybody. So the first one, we see A. He did 35 laps and it took him 84 seconds. For B, he did 42 laps and it took him 96.6 seconds. Lastly, C did 38 laps and it took him 102.6 seconds. Now, this problem, we have a trick way to do it, but it won't always be like that. Let's look at this. B had 42 laps and C had 38 laps. Who had more laps, B or C? Who had more laps, B or C? Let's see. B, we said B. And who had more time? Who took more time to do it? Raising our hands. Let's see, Hannah. C. So if B had more laps and took less time, do you think C's going to be the fastest? No. So we can automatically cancel that one out because we know that just doesn't work. Then what we would do is we already set it up into a ratio form. We want to simplify as best as we can. So let's take some time to do that. Here's the easiest way to do it. 35 and 84, those don't have anything in common. We can't really divide by that. 42 and 96.6, that's hard. But what we can do is we can set these two equal to each other and then see which one is less. So What do 35 and 42? What's their greatest common factor, Daniel? Their greatest common factor is 7. Exactly. So we're going to set them up into ratios of 7. So for A, it becomes 7 over something. We'll get there in a second. And for B, it becomes 7 over something. What did we divide A by to get 7? What did we divide A by to get 7? Who can tell me? Trey.
5.
We divided by 5, so we're going to divide 84 by 5. What did we divide B by to get to 7, Lucy? 6, so we're going to divide 96.6 by 6. So do that on your paper. When we divide 96.6 by 6, we get 16.1. Who has 84 divided by 5? Gore, what is 84 divided by 5? 16.8. So, which one was faster? Who can tell me which one was faster, Trey?
B.
B is faster. B is faster. Devin wrote the rate 108 in 6 weeks as a unit rate. Find her mistake and correct it. So I wrote 108 over 6, and my unit rate was 54 over 3. What's my mistake, Michelle? A unit rate has to have 1 on the denominator. That's the mistake. So, what would our correct answer be? How do we get from 3 to 1? We do what?
Divide by 3.
We divide by 3. So we do the same to the top. We divide by 3. And what do we get? 54 divided by 3. Take your time. Romario, what's our answer? 18. So our unit rate would be 18 over 1. A lot of you guys said she needs to flip it or she needs to do stuff like that. No, the only thing is when we're dealing with unit rate, it must be over 1. Again, let's look at this one. Write the unit rate. 162 water bottles in 9 cases. How would we set this problem up? 162 water bottles in 9 cases. How do I set that up, Lucy? I do what? Yep, 162 over 9. Now, we know that the only factors of 9 are 3 and 3 and 9 and 1. So, try those. And we know it has to be a unit rate, so we know it has to be over 1. What's the answer, Lucy? It's what? 18 over 1. Exactly, 18 over 1. That's our unit rate. Once again, if you didn't know how to do this, you can split it or you can do long division. Next one that we're doing, we have 2 more. Complete the ratio table. Everybody should be able to complete this ratio table. Now, the easiest way, there's many ways to complete this unit table that I saw. A lot of them were pretty genius. We're going to just do the most simple way. What is the greatest common factor that 16 and 12 have in common? What's the greatest common factor, Rafi? That is not the greatest common factor. 8 is not the greatest. Rocco? 4 is the greatest common factor. So, how do we go from 16 to 4? What do we do, Michelle? Divide by 4. And then how do we go from 4 to 12? How do we go from 4 to 12, Malia? Times 3. What we do to the top?
We do the bottom side.
Exactly. So, what's 80 divided by 4? Who can tell me? Let's see. Romario. 20. And then, what's 20 times 3, Miles?
60.
Excellent. Congratulations. You guys just finished the ratio table. The last one, I want you to correct the error. Let's see. We have to correct this ratio table. What do you think the person was thinking when they made these errors? What do we think, Gore?
They were subtracting and adding.
Yeah, they were doing subtraction and addition. So they did -1 here and then plus 14 here. And we see that same thing, -1 here, plus 14 here. When we do ratio tables, do we do addition and subtraction?
No.
No, we do not. We have to do multiplication and division. So, how do we get from 2 to 1? What do? We divide by 2. And then how do we get from 1 to 15? Trey?
Multiply by 15.
Easy. So, what is 6? I want everyone to call it out at the same time. 6 divided by 2 is?
3.
And what is 3 times 15? Call it out at the same time.
45.
Excellent. That is the answer. Let's look. Okay. Celine earns $25 an hour tutoring. I want you to complete the chart, and on the next page, we have the graph. Gloria is going to be our teacher right now. So she's going to fill out the chart accurately. Let's watch. Check to make sure you did it.
I feel like I'm...
Excellent. Who agrees with her work? Raise your hand. Look at that. That's basically the entire class. And if you aren't, then you're wrong because this is correct. Excellent. Gloria did great work. Now I want to ask you, what is an ordered pair?
Okay.
What is an ordered pair, Hannah?
An ordered pair is like, it's mainly used with like charts.
Yeah, it's used for charts. So in the first ordered pair, if we look at it, when we do it, it's got X's and Y's. Which one comes first, the X or the Y? Trey?
The Y.
The Y comes first. Who agrees? No. What comes first, Romario? The X comes first and then the Y. We can remember that because it is alphabetical order. X, Y, and then Z, which we don't deal with until much later. So here would be the graph. So if we did this graph, and if we did it a little bit better than I drew it, we have 1 and 25. We have 4 and 100. We have 5 and 125. We have 7 and 175. And we have 9 and we have 225. Hey, what does that make? What does that make, Adriana? Yeah, it makes pretty much a straight line, more or less. My graph is off because I hand drew it. But it makes a straight line. If you have a graph, if you're graphing this and you're getting points like this, then you know that there's something up. All of these, it's a ratio, make a straight line. Okay, next 3. Determine if each ratio is equivalent. Once again, you set them equal to ratios and see if you can get them equal to one another. Do that on a separate sheet of paper. One thing we want to do, the easiest way is get our denominators equal. 3 and 5. What is the greatest common factor between 3 and 5? Trey? No, Romario, what's the greatest common factor? 1. So we have to divide to get them to be 1. So we divide this by 3 and this by 5. This next one, who happens to know what the greatest common factor between 45 and 135 is? Do we know? Daniel? Who knows? What do we think, Gore? 15's a really good guess. We could even use 15 for this. It actually is 45. Now, even if you don't know the greatest common factor, just keep simplifying until you get the same denominator. There's nothing wrong with that. And similarly, the greatest common factor of 28 and 560 is actually 28. But like I said, if you don't know it, just start dividing. If they're even, divide by 2. If they're end with a 5, divide by 5. Do whatever is the easiest way for you. It doesn't matter unless you're doing what's easy. So simplify and answer if the first one is equal, second one is equal, third one is equal. They should be yes or no answers. What's 96 divided by 3? What's 96 divided by 3, Daniel? You forgot? What's 96 divided by 3, Trey?
36.
Not 30. Yes, 32. What is 160 divided by 5? What's 160 divided by 5? Does anybody know? What do we think, Trey?
32.
32. So, is this first one, are they equivalent?
Yes.
Yes. So the first one is equivalent. Now let's look at the second one. We'll look at the second one. Now, once again, we could divide by whatever we want. In this case, it's easier to just keep the bottoms at 45. So, now, how do we get 135 to equal 45? How do we get 135 to equal 45? Who can tell me? Lucy? Divided by 3. So we get 45 here, we get 45 here. This stays the same as 15. And what's 45 divided by 3? 45 divided by 3. Who else can tell me? Yes, Rafi? 15. Are these two equivalent?
Yeah.
Yes.
They're equivalent fractions.
Last one. So we're going to check our last one. Now, I already told you that we can get them to equal 28. Like I said, it doesn't matter how you do it on your test as long as you're doing the right thing. We can do 28 and 28. What do we divide 560 by to get 28? The hint by that is to divide 560 by 28, and whatever your answer is how you can make it into 28. So what is 560 divided by 28? I'm really impressed. What do you think the answer is, Gore? 20. So we divided it by 20, right? So what is 240 divided by 20? What's 240 divided by 20, Lucy? It is 12. Yes. Is 16 28ths equal to 12 28ths? No. So that one is not equal. It is yes, yes, no. Exactly. Yes, yes, no. In 10 minutes, a heart can beat 700 times. Our initial ratio would be 10 over 700. Really easy. We want to find out how many times it beats in 140 minutes, or 140 times, and then how many minutes it takes to beat 630 times. Here's the easiest way. Let's simplify this first fraction. 10 over 700. Or how can I simplify 10 over 700, Michelle? Divide by 10. Just cross off my zeros. I get 1 over 70. Excellent. How do I go from 70 to 140? What do I do? Rocco? Times 2. So 1 times 2 is 2. So our answer here is 2 minutes. Next, again, let's look at this 70 to 630. How do I get from 70 to 630? It's the same as going from 7 to 63. Rafi? By 9. So what do I multiply the 1 by? I multiply it by 9 and I get 9. So this answer right here is 9. That's the easiest way to do these ratios. It's super duper easy. Okay. The table shows, this was really hard for a lot of you. The table shows people's favorite subject. How many students out of 400 like math? So we need to set up our initial ratio, and then we need to get it out of 400. So find the initial ratio for me. Lucy, what's our initial ratio? 6 to 20. Exactly. 6 students like math, 20 students total. This is easy. How do we go from 20 to 400? Jaden? Times 20. So we do the exact same to the 6. What's 6 times 20? Who can tell me? Miles? 120. And our answer is then 120. Exactly. So, a lot of people messed up on this one because you did not read. What is the least common multiple of 6 and 9? Multiple, not factor. Multiple, not factor. Yes. What is it, Michelle? No, multiple, not factor. Gloria. It is 18. So we get our answer to be 18. Here's how we do it. We have 9. Then it becomes 18, 27, 36. We have 6, 12, 18, 24. Hey, look at that. Least common multiple? 18. Pay attention to the words. Least common multiple. Okay, these ones are easy. We write the ratio as a fraction. I want you guys to count this, okay? I want you guys to count the hearts and count the sad faces and all of that. I'll make it easy for you so you can see. We're gonna do A first. What's the initial fraction? AKA, how many stars are in the initial fraction? How many stars, Daniel? 2 stars. How many hearts are in the initial fraction, Daniel, again? No. How many stars?
Eight.
Or
Eight.
how many hearts? What do we have, Nathan? 8. Is that our answer?
No.
We have to simplify. Lucy, what's the simplified fraction? 1/4. And if we explained it, what it means is 1 star for every 4 hearts. Next one. Let's look at this next one. We have the smiley faces to frowny faces. How many smiley faces do we have? Who can tell me how many smiley faces we have, Gore? We have 10 smiley faces. How many sad faces do we have? How many sad faces, Rafi? 6. Is that our answer? Is this our answer?
No.
What do we have to do? We have to? What is the simplification of this, Miles? 5 and 3. What that means is we get 5 happies for every 3 sads. Exactly. 5 happies for every 3 sads. You had to explain it. You had to tell me what it meant. You could write it in either direction. You could have written 3 to 5 as long as you explain what it is. 4 students spent $12 on a school lunch. What's the initial ratio? 4 students spent $12. Initial ratio? I want to see the initial ratio. Matthew. 4 to 12. Can I simplify that?
Yes.
What do I get, Trey?
1/3.
1 to 3. Exactly. It says at this rate, how much would 10 students spend total? If this is my students and this is my money, we want to get to 10. How do I get to 10 from 1? I multiply by 10. So I do the same on the other side. What's the answer? 30. The answer is simply as easy as 30. Exactly. This one's tricky. This is a tricky one. Jersey Mike's made 27 sandwiches using 12 pounds of turkey. What's the initial ratio? What's the initial ratio, Hannah? 27 to 12. How much turkey was on each sandwich? How much turkey was on each sandwich? If I want each sandwich, what does each mean? What does each mean, Romario? 1. It means 1. How do I go from 27 to 1? I do what? Divide by 27. I'm going to do the same thing here. 12 divided by 27. We look for our greatest common factor. What is the greatest common factor between 12 and 27, Lucy? 3. What is 12 divided by 3? Who can tell me? What is it, Daniel? 4. What is 27 divided by 3? Who can tell me? Trey. 9. So guess what our answer is? 4/9. That's our answer. Our answer is 4/9 of a pound. Great job, you guys. We completed test number 1. Tomorrow we will be doing test 2.